Okay, finding reference angles. Reference angles are always drawn to the x-axis, and that is very important. Some students get this mixed up and try to draw them to the y-axis, but we really have to get down that we want to draw these to the x-axis. And the computations are going to be slightly different based on whichever quadrant the initial angle lands in. So quadrant one, an angle that just fits into quadrant one, when you draw an angle from wherever the terminal side of the initial angle lands, you draw it to the x-axis, it's just going to fit and be the exact same as whatever t was. This angle is also going to be our reference angle. But when you draw it into the second quadrant, if your initial angle t goes into the second quadrant, you're going to draw this to the x-axis, and your reference angle is only going to make up this portion right here. Okay, so what that means is to make that computation, you're going to go with pi, or 180 degrees, minus whatever this angle was that comes around this far. So pi minus whatever the initial angle was, or 180 degrees minus whatever the initial angle was. That's going to also be different if you're in the third or fourth quadrants. So in the third quadrant, your initial angle wraps all the way around somewhere, lands here in the fourth quadrant, and then you're going to draw your reference angle back to the x-axis. So it's really this angle in here that you're trying to figure out and do that computation. So what you do is you take whatever the further side is, t is this angle that lands all the way over here, and then subtract away that 180 degrees, or pi. And finally, the fourth quadrant, your initial angle wraps all the way down here, and the terminal side lands into the fourth quadrant. If you want to draw in that reference angle, it's just going to be between wherever that terminal side is and the x-axis. So that x-axis is going to be at either 360 degrees or 2 pi to end up going that far around. Okay, but as you kind of look at this angle that I've drawn in here, the further side going further around here is going to be the 2 pi, or the 360 degrees, minus the shorter side of this angle is going to be t, whatever that angle is. Let's do a couple of these quick examples so you get the hang of this. It's really not that bad, but it's going to be a little bit different based on whichever quadrant you end up in. All right, so our goal here is to find the reference angle, and finding reference angle is really, really important as we go through these problems. So we want to find the reference angle of 225 degrees. So I've kind of gone ahead and drawn in our quadrantal angles. So like 0, 90, 180, 270, and 360. Get really comfortable with those. It means a bunch as you're trying to work these problems. Okay, next we just kind of need to locate which quadrant is 225 in. Well, it's not between 0 and 90. It's not between 90 and 180. It's bigger than 180, but smaller than 270. So it's going to land out here in the third quadrant. So to draw that around, this initial 225 wraps around all the way around here. Next, let's try to go ahead and draw in what's our reference angle look like. Well, our reference angle always gets drawn to the x-axis. So it's going to be the angle in here that we're trying to do the computation for. Sometimes we use t, sometimes we use theta. I'm going to go ahead and say theta bar with that line above it is going to represent our reference angle. So doing that computation, in this case, what you're going to do to compute theta bar is going to be the further of these two angles that make up what I've drawn in blue here. The further one is the 225, right? 225 wrapped all the way around and lands here. So you always take the bigger of the two numbers, 225, and then you want to subtract away the shorter of these sides, which is going to be the 180. So 225 degrees minus 180 degrees is going to land us with 45 degrees is going to be our reference angle. And that would be our solution on this one. These have a bunch of nice applications, by the way, and understanding how to compute or find these reference angles is going to be really, really important as we keep moving forward. So let's try another one. This time, let's use radian measure. So in this case, we have 5 pi over 3, which is an improper fraction. That's the first thing to note. I've also gone ahead and put in our quadrantal angle. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, an improper fraction is bigger than a whole pi, so it's not going to be in quadrant 1 or 2. It's bigger than 1 pi. 3 halves is the same thing as 1.5, 1.5. 5/3, though, that's going to be bigger than 1.5. That's like 1 2/3. If you wanted to rewrite that as a mixed numeral or get a decimal for it, 5 divided by 3 makes 1.6, 1.67, which is bigger than 1.5, which is 3 divided by 2. So the important thing is it ends up in the fourth quadrant. So 5 pi over 3 comes around this far. But our reference angle is always drawn to the x-axis. So it's going to be what's in red here. So if I want to label that as theta bar again, this computation would be the further of these two angles would be, if you wrapped all the way around, would be 2 pi minus the shorter of these two sides would be this angle here, which would be 5 pi over 3. All right, so to do this computation, we want to get a common denominator. I would aim for 3 as our common denominator, and we can rewrite 2 as 6 divided by 3 is equivalent to 2, bring the pi along, minus 5 pi over 3. Hopefully that makes sense. If I visualize this as 2 over 1 as a fraction, I can multiply numerator and denominator each by 3. That would get us to this 6 over 3, or 6 divided by 3 is equivalent to 2. Just working with fractions, getting a common denominator, and then we can do the subtraction once we have the common denominator. If you have 6 pi's and you subtract away 5 pi's, you're left with 1 pi. Keep that common denominator of 3. So our reference angle in this case is going to be pi over 3. Again, understanding how to make these computations is going to be really important as we move forward, and in subsequent videos use these reference angles to get more extra information. All right, good luck.